High-performance compute systems are shared among multiple research teams that generally use different programming languages and require different software packages and tools. For this reason, most HPC systems are provisioned with a general set of tools upon which users can layer the tools and software packages that they need. The LLSC systems provide the tools shown here. Each research project only needs a subset of these tools. This video will illustrate how to set up your environment with the tools you need to develop and run your applications. In particular, we will demonstrate the use of modules, which provide an easy way to load a particular version of a language, compiler, or software. To work with modules, you will need a terminal window logged into the system. At the command prompt, type the command module avail to see what modules are available on the system. This video is being made in April 2020, so your module list may vary from what you see here, but the commands and the approach are still the same. Please note, a list of common module commands is on the reference guide, which can be downloaded from our web pages. To load a module, use the command module load, followed by the module name. For example, if we want to use the newest Anaconda module, we execute the command module load Anaconda 2020B. To check and see which modules I've loaded, I can use the module list command. In this case, it returns Anaconda 2020B. If I decide that I really want Anaconda 2020A, I can use the module switch command with the name of the module I have, followed by the name of the module I want to use. This command is especially important because the environment setting from one module may conflict with the environment settings of another module, so you want to explicitly switch them. So in this case, we have module switch Anaconda 2020B, followed by Anaconda 2020A. Again, I'll use the module list command to confirm that I have switched modules. Now imagine that I need to work on a very different project with very different modules. Say I'm switching from working in Python to working on a C++ program that I need to parallelize. In this case, I can unload the Anaconda module because I won't need it, and then load the C++ compiler and the MPI modules. Module unload Anaconda 2020A, module load ICC 2019.5, module load MPI OpenMPI-4.0. And again, I want to check on the modules to make sure that I have the correct modules loaded. Module list. Now, I no longer have Anaconda 2020A. I have ICC for the Intel compilers, and I have an MPI for the message passing library. Notice that I've been working with modules at the command line. When batch jobs are submitted, they run on a remote processor that will only have the basic software tools that we mentioned at the beginning of the video. To make sure that my environment is set up properly for my batch job, I need to put the module commands in a script. We'll demonstrate how to use these scripts when submitting jobs later in this course. To create your shell script, open an editor. I use VI, but you can use any editor that you're comfortable with, or open the editor tool through the Jupyter Notebook if you aren't familiar with editors. I will call my script myscript.sh. The first line in the script will set my shell to bash. The second line is a comment, reminding me that I am initializing the module command. The third line, source/etc/profile, initializes the module command. The fourth line just basically tells me that I'm going to load the modules below. And finally, we're going to start loading our modules. In this case, we'll load module Anaconda 2020B, just as we did before. Module load, Anaconda 2020B. We'll save the script. And then, as I said earlier, we'll detail the job submission process where you'll use this script later in the course.